Aloha, everybody, and good morning from Hawaii Volcanoes National Park on the Big Island of Hawaii. As most of you know, there is a new summit eruption. I apologize for the technical difficulties. We were trying to get the video of me synced up with the video of the eruption. Um, most of you most of you have been watching this on YouTube since the eruption started. It began at about 2:20 this morning after about a half an hour of precursory seismicity. It was a fairly rapid onset for one of these eruptions. This is the fifth eruption that we've had in the summit area of Kilauea since December of 2020. And as you've noticed, there's some very large fountains playing in the southwest corner of Halemaumau crater, which is in the southern half of Kaluapele, or the summit caldera of Kilauea volcano, up here near the main entrance of Hawaii Volcanoes National Park. The lava is coming out at a very rapid rate, as it usually does at the onset of these eruptions, along with a large volume of volcanic gas, mostly SO2 and water. The lava flows have already covered the old lava lake that began in December 2020. The surface of that lake is several square kilometers. It's about a kilometer in diameter. And that entire surface area is covered with moving lava at this moment. So it's a pretty exciting time. It's very early in the morning. This eruption we're just getting around just a little bit before 6 o'clock right now. And thank you all for joining us. And a special thanks to all of our friends in the National Park Service who make all of this viewing possible. So the National Park Service is preparing for a lot of live visitors this morning, just the way that we're working with you guys to bring this video to you on YouTube. I have control of the camera that we're looking at, so I'm going to zoom out and let people see what the size of this eruption is so far. I'm going to move away from the vent for a moment. And you can see the lava coming from that southwest corner of Halemaumau out into the center. And then we're going to move over to the left a little bit further. And you can see there's some little fountains in the middle of the lava lake. And this lava lake is quite large. It's going to take 3 pans to move across it in a wide angle setting. It is overflowing what was the original Halemaumau crater and moving on to a downdrop block of what was used to be Kaluapele's floor. So that dropped a couple hundred feet during the 2018 eruption. So this is a really big voluminous eruption, and it was preceded by a spike in inflation at the summit and a real intense swarm of earthquakes as the crack opened up and magma moved to the surface. We don't have very good sound that we can give back to you guys, but the reports from our field team were that this sounded a lot like a jet engine when they arrived up there, and it's a little bit quieter now. The high point of the fountains, they were at about 80 meters, which is over 200 feet tall, or 90 meters, which is over 200 feet tall. And they've dropped about 10 meters or about 30 feet to the current height of the fountains. So we can come back in here to the southwest side, and we're looking almost due south with this camera. And if you connect the vents in here, the vents are aligned in a northeast to southwest direction, which is the primary direction of cracking on the caldera floor and also in both rift zones. So it's lined up with what we know to be the structural weakness that lava tends to emerge into the crater. Hold on just a second. I'm trying to get to the place where we have questions. Oh, people are looking at the thermal image. The thermal image right now is just showing what is hot. Right now, we don't have it well calibrated, but the surface of the lava, which is mostly the crust in there, is usually around 500 degrees C or someplace in there, which would be about 1,000 degrees Fahrenheit. The lava is about twice that temperature. So if we could just see completely incandescent lava, the temperature would measure about 2,000 degrees Fahrenheit or about 1,000 degrees, about 1,100 degrees Fahrenheit. So it's quite warm, and the surface of the lava puts off a lot of heat. So the air convects up strongly from there, and it's moving the gas upwards as well. We can kind of zoom in on the vent here. And the map on the bottom left is showing the extent of lava flows prior to this current eruption. So the pink is the area that was covered prior to this eruption by recent lava flows. And that pink color in there is about the size of the current lava lake. So it's about a kilometer in diameter or so of what we see, and it makes it right now that puts it up in the category of one of the biggest lava lakes on the planet. So when we get this thing going, it is quite an exceptionally large lava lake. Since 2020, in the eruption that started in December of 2020, the area beneath the lava lake was 1,000 feet deeper. So we've got about 1,000 feet of lava filling in this area. And most of that lava, probably 50% of it or more, is still liquid underneath this crust that's formed on top of it. So we're just stacking up lava by lava by lava, and we know it takes many decades for it to cool completely in here. Yeah. And you can use that map on our webpage to access the data from our seismometers and our tilt meters, and also to find our camera images if you want. We also have separate pages for the still images from the cameras as well. The question is, other than the earthquakes, was there any sign that we were about to experience an eruption? And earthquakes are definitely the primary way we look at these things. And starting a couple weeks ago, we noticed that seismic activity or earthquakes were starting to pick up beneath the caldera. And that is since September, when we had an eruption out on the upper east rift zone, so about 10 or 15 kilometers to the northeast of the summit. And it was interesting to see all of our seismicity had been located over in that area for many months. So the seismicity returning back to the summit was kind of an indication, and it occurred in small swarms of tiny earthquakes. So we changed our daily updates, well, our updates from weekly to daily about a week ago, as we saw this activity pick up, with a notice that we think that the volcano is starting to move towards eruptive activity again. But there's no real indication of when that's going to happen. And the onset of this was very rapid. We had kind of normal background activity through most of the night. At about 1:30, the seismicity really picked up this morning. And by 2 a.m., we could see that we were measuring seismicity related to a crack that was opening, being forced open by magma as it moved towards the surface beneath Halimau. So, and at 2:20, we saw a glow on the webcams and lava had made the surface. So it happened relatively quickly. This is one of the shorter lead times that we've had to an eruption up here. And all of these near the summit, the lead time is very short because the magma chamber is only 1 to 2 kilometers beneath the surface, so less than a mile below the surface of the volcano. And it doesn't take very long for those cracks to propagate and open up to the surface and let magma out. And what's driving this is that when you're about 500 meters down or somewhere around 1,500 to 2,000 feet below the surface, we have water and sulfur that are dissolved in the magma. And that water and sulfur, it's very much like if you have a sealed soda can or soda bottle that you have CO2 dissolved in the soda. When you open it up, the CO2 can come out. And it's the same thing with the water and the sulfur. It starts to what we call exsolve. It leaves the melt and it actually starts to form bubbles. These bubbles expand very rapidly because the steam is not at boiling temperature, it's at the temperature of the lava. So it can expand in volume by as much as 500 to 1,000 times its original volume. And that volume expansion is what's driving the magma out of the ground into these high fountains. And we can see that we have this very large gas plume that this is producing, as well as all of the spatter, these blobs of lava that we're seeing being tossed in the air on the video. So I'm going to zoom in real close so we can kind of see some of the spattering in here. And this kind of volcano, Hawaiian volcanoes, the lava is relatively fluid. It's it's a type of lava that we call basaltic lava. It typically has a silica content of about 50% of the lava is made of silica, SiO2. If we think of something like Mount St. Helens, about 2/3 of that one of those lavas are silica, and something like Yellowstone, it's about 3/4 of the lava is silica. The more silica in the lava, the stiffer it gets. So we can think of basaltic lava as kind of like water. Um, the lava out of Mount St. Helens is more like mayonnaise and or spaghetti sauce, and then the Yellowstone lava is more like peanut butter. So if you think of bubbles getting caught in those things of steam, what happens is for the water, the bubbles just come out and they flip some water up. For spaghetti sauce, they start to actually break the spaghetti sauce up. And for peanut butter, they would throw globs of peanut butter around instead of liquid. But you can see almost all of this lava that comes out as spatter is landing back inside and dropping down and becoming liquid again. So these things are very much like jello blobs, but they're like the weight of a rock. So it's really like if Jello had the weight of concrete or a rock or something like that. They're not pleasant to get hit with. They're very hard and they're very heavy. So you want to stay out of the way of these blobs as they're falling down. And so the blobs that we're seeing in here are several feet across, right? So they're actually really big globs of lava that are being tossed around. What we can't see here in the darkness right now is the finer material that's cooling. So we have Pele's hair and little pumices that are cooling and being taken up by the hot air off the top of the column. And those things are being carried up onto the rim of the caldera, as well as some of these big spatter blocks are being tossed up there as well. And I just got a note from our field team that the gas had lifted kind of downwind of the vent and they were able to go out and collect some of these clasts. And we collect these little pieces of lava because what we can do with them is, one, we can tell the temperature of the lava from the composition of the glass. It's particularly sensitive to magnesium, and so we can see what the temperature was. We can also look at the composition, and in some of the little elements that we call trace elements, they change and allow us to fingerprint where in the magma chamber these lavas came from. And of particular use are the olivine crystals that form in here, the little green mineral olivine. It actually records the temperatures and it can record the pressure of the area where the olivine crystallized. So oftentimes we see it started to crystallize deep, was transferred up to a shallow magma chamber, and then erupted. So what we can do is see, is this the same lava that we saw erupt? The last eruption in Halemaumau crater was in September of 2023. So we want to know, is this the same lava? Is it new lava injected into the old lava, or is it entirely new lava that's being supplied from deeper in the system? So if you're thinking about going up to see this in person, the Park Service will direct you to the best places to view, but it is quite visible from all the way around the north side of the caldera that is open to the public. So no problem seeing the activity from anywhere from Keonekakoi Crater to Waldron Ledge over to the Volcano House or over to Kilauea Overlook or all the way to Uikahuna Bluff. The lava and the lava lake will be visible at any of those areas. So one of the questions was, does this eruption mean there's a lower probability of another rift opening like at Mauna Loa? And so there's a couple pieces in there. First, Kilauea and Mauna Loa are independent volcanoes. They don't share the same source for the most part, and they erupt more or less independently. There's some relationships between them, but there is no problem with Mauna Loa erupting while Kilauea erupts. And as a matter of fact, in the last two eruptions in 2022 and in 1984, both Kilauea and Mauna Loa were in eruption together. So it doesn't preclude it, but Mauna Loa right now is quite quiet. We don't see any indication of it being preparing for an eruption at all at the moment. So we're not expecting that. In terms of going down the rift zones, uh, Hawaiian volcanoes have a central magma chamber, and then because they're elongated, that elongated direction of the volcano tends to be weak, and it means that from the central magma chamber, cracks can propagate outward and down what we call the rift zones, which is this weak direction. And we did have an eruption out at Nepal Crater in September of 2024, and we saw seismicity move out in that direction. Right now, we're not seeing any seismicity either going to the northeast or the southwest of Kilauea's summit area, which is into either the southwest rift zone or the northeast rift zone. So we're not expecting magma to move out there, but as eruptions go on, it's possible that it could move there, but the possibility seems very, very low right at this moment. it's more likely that this eruption would end and then activity might migrate into one of the rift zones, or it might return to the summit. So these are really beautiful events. I'm going to zoom back out again to leave this back where we found the view in here. And if there's no more questions, I'm going to sign off because I have a few other things to do this morning. As you might imagine, we've been pretty busy and pretty eventful morning, and we're out busy collecting data and making sure we get the best information to our partners with the Park Service as possible. So thanks everybody for watching the channel. The USGS is proud to serve you in the best way we possibly can.